Now, as with most properties, whatever property we had for multiplication will work with division, but we're going to do the reverse with division. Instead of bringing two identical roots together, we're going to split up one big root and break it up into two parts. So on these, we're going to have one big root on an entire fraction, and what we're going to do is break it down into two of the same roots, whatever they were, on taking the root of whatever was on top and the root of whatever was on the bottom separately. So what does this mean? This means on A that we've got a square root here, that I will have a square root of whatever's on top first, square root of 16, over a square root of whatever's on the bottom, the 49. Well, we know that the square root of 16 is 4, and we do know that the square root of the 49 on the bottom is 7. So we're going to get 4 over 7, which is already reduced. So we're done. Let's look at the next one. On B, we've got another square root. So that means we're going to take the square root of whatever's on the top, which is the 13, and the square root of whatever's on the bottom, the 49. Now, I can't actually take the square root of 13. You can't do anything with that. It's a prime number, so I'll leave that as the square root of 13. However, I can take the square root of 49, that is 7, and we'll leave that as is. Let's look at C. In C, again, we've got another square root. So we'll take the square root of the top first, so that'll give us the square root of k, over the square root of the bottom, which is 100. Again, I can't take the square root of the k on top, but I can take the square root of the 100 on the bottom. The square root of the 100 on the bottom is just 10. Square root of k, though, it's got to stay as is, so that will stay as square root of k, and we're done with C. In D, we've got something different. We've got a cube root. So I'm going to still break that up into two identical cube roots. So we'll have the cube root of the t on the top and a cube root of the 125 on the bottom. Again, I can't do anything with the cube root of t. That's going to have to stay as is, but I can take the cube root of 125. What number multiplied by itself 3 times gives us 125? Well, that's just a 5. So we'll have a 5 on the denominator. So we get the cube root of t over 5. Last one. On E, we've got, let's see, a square root that we'll take. So we'll start out with the square root of the top, which is 16, over the square root of the bottom, which is x squared. Well, on top, the square root of 16 is 4. Now, as a reminder, we've got a square root on the bottom. That's a hidden 2 for our square root. What that means is, remember, the denominator of our fractional exponent will be 2. So this means I'll have an x squared because there was a 2 on top. And we'll have a 2 on the bottom because the root always goes on the bottom. Well, remember that 2 over 2 is just 1. So this will become 4 over x to the first power, which is just 4 over x. Another way you could have done this exact same problem is remembering that square roots and squares will actually just cancel one another out, leaving you with just the x underneath. Either way, as long as you're getting to the same answer, that's all that matters.